Go over the speed settings. The print speed has a huge effect on the overall quality of the print. If you look at this example of these owls at 10 millimeters a second, you end up getting a pretty good looking print, but at 120 millimeters per second, you end up getting a pretty crappy looking print. One of the reasons for this is as the filament is being fed through the extruder at a slower speed, the extruder has more time to provide uh, a more consistent filament, liquid filament coming out of the extruder, out of the nozzle. At a higher speed, it just doesn't have that amount of time to provide the consistency that it needs to lay down a good layer. If you'll look here, kind of looks like as the filament was being extruded, like there may have been clumps in it. It may have not even been properly heated, so it's kind of pushing out clumps of filament, leaving gaps, and it's just all over the print. Another reason why, um, and this here is kind of a slow motion example, or it will get to being slow motion, I think. Yeah, if you notice here, it's just really thin. It's just not liquid enough to lay down a consistent layer. At 5 millimeters, it looks pretty good to me. 10 millimeters a second, it looks pretty good to me. As you get higher than that, it just ends up getting all these inconsistencies and defects in the layers. So another reason why printing at slower speeds provides a better print is because at a slower speed, you give the filament enough time to cool down, shrink to its room temperature or lower temperature um, volume. So the faster you print, the more the lower layers are actually going to still be cooling down and shrinking. That's why you'll get this warping. That's why you get the corners lifting up of the print because they're just not cooled down and they're still shrinking as it's being printed. Another reason is because the faster your head is moving, the faster the plate is moving, the more force it's providing to actually rip that print off of the build plate and cause initial layer failure. If you'll see in this print, it gets all the way to the top and it's nearly done. Um, if he would have slowed this print down, it would have had a lot better chance of actually staying adhered to the build plate. Okay, so the infill speed, you actually want to keep that pretty low because in the infill, you generally have a lot of direction changes. You can cause a lot of print wobble. You can cause a lot, there's more force in the infill to rip off the initial layer to cause support failures because of that rapid direction change. So I generally want to keep those low. You'll see people put these pretty high, 100 millimeters per second, and then they'll wonder why their prints are constantly failing. Um, so the rest of those, I think, are all the things we just talked about apply to those also. The travel speed. What in the hell? Okay. The travel speed. I also try to keep that low. People try to jack this up high because they're like, oh, it's just traveling. It doesn't matter how fast it's going, but it actually does because whenever it comes to a complete stop and then, or whenever it comes to extruder comes to its destination and stops, the faster you're traveling, the more it's going to over travel. So you're going to start actually traveling in an area that is the over traveled area. So your print isn't going to look the way that you want it to. Um, the initial layer speed, I try to keep that low just so you have a good, solid, consistent first layer because that is the most important when it comes to uh, your print adhering to the plate. So the skirt brim speed, this is one of those that I think you can get away with a lot higher speed. I generally don't because it doesn't add a lot of time to the print, but it doesn't have to have an aesthetic quality. It does have to have a functional quality. So you can jack this up as high as you want with it still remaining functional. The maximum Z speed, to me, this doesn't matter at all. So I put it at 0 millimeters per second so that the firmware on your printer will actually override this setting and just give it the maximum setting that it can possibly have. The reason why I say it doesn't really matter is because it just deals with Z-hop and layer change. And if there's a little bit of over travel on the layer change, it's not going to be a lot because it's not traveling that far at all. And whenever there's a Z hop, it also doesn't matter if it over travels because you're not printing in a Z hop anyways. The number of slower layers actually is just counting each individual layer. So it's like here it says the 2 layers, the first 2 layers are going to be at a slower layer, at a slower print than the third layer. Um, Equalize filament flow. This is for if you have parts of your print that are thinner than the actual layer, uh, the line width. So if you have a 0.4 millimeter nozzle and there's a part of the print that's 0.3 millimeters wide, the nozzle, the extruder will actually move faster through that portion because it knows it's going to as it's traveling faster, it knows that the filament it's laying down is going to be thinner, and it's going to try to use that to compensate for that thin piece because it won't actually be able to print at 0.3 millimeters because it's 0.4 millimeters wide. So to compensate, it'll try to move faster to thin that filament out. Um, Enable acceleration control. This is one of those things that I used to think, and a lot of people I talk to think is a big deal. To me, it actually, I just now have come to the conclusion, let the firmware take care of it, because the acceleration control deals with what happens to the extruder after it's changing direction, after it comes to a complete stop and then starts to pick up speed again. If you look at this video here, you'll notice as the nozzle changes direction, there's a bit of over travel, it wobbles and it wobbles again. I'll let you see that without my mouse being in the way, my cursor. So you see it kind of jiggles like that. So the faster it accelerates to get up to top speed, it's still going to jiggle no matter what. It's just going to happen at a greater distance. So if you notice, it jiggled from about here to here. If you go at a faster acceleration, it's going to jiggle from here to here. But there's going to be that jiggle in there no matter what. If you go at a slower acceleration, it's that the amount of print that it's going to affect is going to be a shorter distance. So if you want to keep that, but it's also going to be more extreme looking. So if you want to keep that jiggle, the effect of it in a shorter distance, then reduce the acceleration. But if you really think about it, the longer that happens, or the further distance that happens, it's actually going to be less noticeable. So I just let the firmware take care of the acceleration. Now the jerk, the slower you can go with your jerk, I mean, really, 10 millimeters is not going to add a lot of time to the print. If you notice at millimeters, we're printing this at 1 hour and 42 minutes. And at 40, which I think a lot of people print at, you're adding, or you're taking away 2 minutes. But the quality of the print is going to be greatly affected. So if you look at here at a jerk of 10, you don't see a whole lot of ringing on this little bendy. If you look here, you see massive ringing at a jerk of 40. So you save 2 minutes at a jerk of 40, but the quality of it is greatly affected. So that's one of those things. Dial it down as much as you possibly can. The jerk is telling it how fast to stop. So the more abruptly it stops, the more the extruder itself is going to be affected. The more it's going to want to over travel. And then travel jerk, same exact thing. You want to dial that down so there's less over travel. Initial layer jerk, same exact thing. Skirt brim jerk, same thing with the skirt before. You kind of want to keep the functionality of the skirt, but as affecting the quality and the aesthetic of the jerk or of the skirt really doesn't matter.